Hello, year 13s. What a crazy world this is. I really thought this was going to be a nice lesson together today, but it's okay. We'll make the most of it. Hopefully, I'll make you a pre-recorded lesson for Wednesday as well. So we're going to take a look at what are functions and how do we define a function. And one of the main ways that we define a function is when we talk about mapping. So mapping is just something which maps one set of numbers to another. So for instance, the mapping might be completely arbitrary or it might have some underlying rule. Most of the time when we talk about functions, there's an underlying rule, like we have a function like x squared or x squared plus 7x or something, but we're going to have some sort of I'm not going to say quadratic. It could be any different power. That's absolutely fine. But we're normally going to have some sort of, let's just use the word equation. And it says that meaning that each value is mapped. So in this one, if x goes to 2x, then that means every value is mapped to twice what it started out as. So like, for instance, if we started with -1, like they have over here, then it would go to -2 because everything would be doubled. There's some different rules about mapping as well. Sometimes you have some numbers that go from one number only to one other number, and then sometimes you have numbers that go from one number to two numbers, or two different numbers go to one. So for instance, like if we had something that was squared and we introduced -2 and that was our input, -2 squared gives us 4, but obviously so does also +2. So we can get the same outcome or the same output from two different inputs. So that's pretty much what it says down here as well. Also notice that one input might map to multiple outputs or multiple inputs to one output. Notice also that not all values in the set of inputs necessarily have a mapping to a value in the set of outputs. Some really important things for us here. We've got two possible new words. We've got the domain and we've also got the range. So the domain is all of the possible sets of inputs. These are usually our x values because normally when we're looking at our functions, we're normally looking at a function in terms of x. So the domain is most often the x. There's going to be a time when we talk about where it's not going to be the x. And the range is just the set of all possible outcomes or outputs. So the range is usually associated with the y values. Okay, so specifically, you might get asked, what is a function? And a function is a mapping such that every element of the domain, so the x, is mapped to exactly one element of the range. There's so many things I can tell you right now, which is kind of the problem. So most things that we draw, like a quadratic graph, a straight line graph, a cubic graph, a quartic graph, all of those are going to be functions. They all have one value of x that goes to a very specific value of y, and that's absolutely fine with that. So it says our notation is we typically see things written as f of x is equal to 2x plus 1. Sometimes when we talk about a function, we'll write it as f and then the colon and x. It means the exact same thing, and then it says that's written as 2x plus 1. So they really just mean the same thing. You sometimes get asked, is something a function? And it says, for note, we can illustrate a mapping or a function graphically by plotting a point xy. If x maps to y, then for this reason, we would write y is equal to f of x to mean make y the output of the function. So as you can see with the quartic graph that we've got on the left-hand side, the one that looks like a W, it says for each input, the x value, we only get one particular y value output. Okay, and then this is how I learned how to do this when I was younger. I was always taught if you want to check if something's a function, you use something called the vertical line test. So if we drew a vertical line, can it only cross the graph once? So let's see my drawing skills. So if I drew a straight line there, there's only one point where that red line crosses the graph. Same here and here and here. It doesn't matter. As many lines as I wanted to draw, they would only ever cross the graph once, right? So I would say, yes, this is a function. However, the graph on the right-hand side, where we have f of x is equal to the square root of x, look, if we go to try to draw a straight line there, we've got a point of intersection there and there. So no, it's not going to pass the vertical line test, so it is not a function because, for instance, if we take the square root of 4, then we're obviously going to end up with +2, but also -2. So one value of x leads us to two different values of y. So I would have said yes to this one and no to this one. And that's what we're looking for on those. All right, so we have two different kinds of functions we need to think about. We have many to one versus, sorry, I didn't even read that correctly at all. We have one-to-one functions versus many-to-one. So while functions permit an input only to be mapped to one output, there's nothing stopping multiple different inputs being mapped to the same output. I was kind of trying to allude to this earlier when I was talking about 2 squared and negatives 2 squared. So we've got two different functions. First, we have our many-to-one function. So multiple inputs can map to the same output. This is exactly what I was saying earlier. So if we have 2 and negative 2, they both get mapped to 4 if the function was x squared. Okay, and then, but see, we can also check, if you see the graph over here, there is the vertical line test. It's still passing that. That blue line only crosses the quadratic at one point each time. We also have a different kind of function called a one-to-one function, and each output has one input and vice versa. So for the straight line graph y is equal to 2x plus 1, you can see that each of the inputs, 2, 3, and 4, all map to one specific output, 5, 7, and 9. Okay, so a lot of times when they say, they might tell you this function, the function f, is a one-to-one function, and then they might ask you why something is happening with that, and you can say, you know, because it's a one-to-one function. All right, time to actually do some maths now. So it's often helpful to sketch the function to reason about the range. Absolutely, the range is all the y values. This is just a question from your textbook, and it says find the range of each of the following functions. So what I would do is I would definitely go ahead and I would draw each of them. The first line is a straight line graph, but it only wants us to have the domain, the x values of 1, 2, 3, and 4. Okay, should I wow you with my drawing skills? Probably not, but let's try it anyways. So 3 times by 1 is 3 minus 2 is going to give me 1. So that's my first point. 2 times 3 is 6. 4. All right, so something like that-ish. Use your imagination. The picture is actually going to come up on the next slide. So they want us to find the range of the values. So this value right here, where I started, this was 1. That's what happened when I substituted in x is equal 1 into the function. 3 times by 1 is 3. Take away 2 gives me 1. And then my y value at the top here, 3 times by 4 is 12. Take away 2 is 10. So find the range for this one is going to be between 1. So sorry, I don't have my pencil. This is not going very well. So we have is between those two things. So we have f of x, the range, is between 1 and 10. They also want us to say whether or not the function is one-to-one or many-to-one. For all the different values of 1, 2, 3, and 4, it definitely gives me different values for all of the y values. So this one is a one-to-one function. All right, if you want, you can pause here and have a go at the x squared and the 1 over x. I'm actually not going to do them because I'll end up talking for way too long. Okay, the answers are on the next slide, so let's pop over there. There they are. They look a little bit nicer than what I was just trying to do. Okay, but they've drawn all the things just the same. The first one, they didn't draw a sketch because they gave us specific values, but x squared, we know what that looks like, and 1 over x we're pretty confident with as well. All right, let's take a look at another example. Your good old classic piecewise function. A piecewise function is one which is defined in parts. We've definitely seen this in statistics. I'm trying to think of where else we might have seen it. Definitely in further stats. I don't remember if in normal stats or not. I really can't remember right now. We can use different rules for different intervals within the domain. So this one says the function f of x is defined by when x is less than 1, you use the graph 5 minus 2x. So that's going to be a straight line with a negative gradient with a y-intercept of 5. But that is only for values of x less than 1. And then when x is equal to 1 or bigger than 1, then we have a nice little quadratic. So it's not going to be perfect, but it's going to probably look something not horribly wrong from a negative gradient and then, I don't know, maybe a quadratic. I don't know where the two things are going to meet, so it could be something like this as well. I'm not sure until I actually start to draw it. They want us to sketch y is equal to f of x and then state the range of of f of x. So that's going to ask us for all of the y values. And then they want us to solve what happens when f of x is equal to 19. Do you want me to draw it? Oh, should we try this out? What's the worst that could possibly happen? That's never a good start. All right, so let's think, what would happen if we substituted in 0? 5 minus 0 is going to give us 5. So got that one there. And then anything up to but not including 1. 5 minus 2 is going to give me 3. So it goes to here, but it doesn't actually join there. So this is what it looks like for everything less than 1. So this is 1 right there. That point doesn't actually exist. You can try to leave an open circle there. Sorry, it's a really, really thick. I'm trying to draw with my hand at the moment as opposed to my pen because my pen's run out of power. We've got x squared plus 3 for all the values bigger than that. So 1 squared plus 3 is going to give me 4. So that's going to be up here, and it's going to be a quadratic that goes up like that. All right, there's my picture of it. So that's not going to be super great, but that's fine. And then they say solve when f of x is equal to 19. Well, I'm thinking based off of my dodgy sketch, there's probably going to be 2 different values where I get 19. So I'm going to have to check both parts of it and find the different values. All right, you can pause now and try to figure that out, or we can just go ahead and look at the answers. All right, look, their picture is a little bit better than mine, but they did all the same things. So notice right here, they've got that open circle at 1, and that's because for 5 minus 2x, that has to be for x is less than 1, so there's nothing actually exists at 1 there, and then they have a solid circle at the start of the quadratic. And then they said state the range, so what are the values of y? F of x is always going to be bigger than 3 because 3 was the lowest number we ever got to, but the 3 is not actually included. That's why there's no equal to 2 there. And then, just like I was saying, there's 2 points of intersection, so you have to check when x squared plus 3 is equal to 19, and also when 5 minus 2x is equal to 19. And you get your 2 values. All right, I think that's most of the things for today. I think we've got one more thing to talk about, just some exam questions if you want to look at them. So here they are. There's 2 exam questions there if you'd like. You can pause now. You can see that there are question 6 and question 4. So they should be like moderate-ish difficulty. There's only one part from both of them. So they give you the function, and then they want you to say the range, and then they give you another function. This one, they give you an interval, and they want you to find the range as well. Okay, again, the answers are on the next slide. So you can either look at the Google Slides, or I'm going to pop over to that one right now. All right, there you go. There's the answers. I think that's us mostly done. I mean, like, I could sit here and chat about this forever, but that's us done. So there you go, exercise 2B if you'd like to do some maths today, and I'll make you another lesson for Wednesday. Chat to you later. Bye.